Welcome back to Formations. Now, we're going to learn about something that you probably already learned, but it's necessary that you need to learn it again and again and again and again and again. Because negative numbers, they're just something useful in real life. What's a negative number? It is a number that is below 0. As you probably know, there's a lack of other voices here. And the reason being is that they're on vacation. It's not really doing so well with everyone else. Within this series, they don't really like this series. I'm gonna have to leave them alone for a while. A number that is below 0. What is 0 in respect to the number line? It is in fact not really the center, because almost any number is the center if it's infinite, because you don't have a highest number or lowest number, if you don't count aleph no. But that still doesn't make 0 be between the positives on the right, so that's going to the right, and the negatives in the left. So if you're going to have a number that is below 0, it's to the left. And what's opposite of left? Right. That's right. Because you have 1, 2, 3, and so on, and you have -1, and you go backwards, -2, -3, -2019, and you'll see the pattern. Even if the number increases, it's still negative. You're still gonna have something completely small. And in fact, it is something that is theoretically smaller, but we still use it in many different applications. Many different applications today. Hey. Such as debt. D-E-B-T. So even though you can't really see it, it's right there. It's theoretically possible. So let's say you have $5. And then you just, if you lose, or in a way owe someone $8, if you owe $8 to a company and you already have $5, you're pretty poor. That equals -$3. It still makes sort of sense because you're $3 in debt. This pen does not work. There can be many problems when it comes to adding and subtracting negative numbers. Because if you are subtracting something from something, then the thing that you're subtracting from could be greater than the other something, and it can make that something negative. In other words, if you have two numbers, A and B, and if you're subtracting A and B, if those two numbers are positive rational numbers, which does include, let's say 3/4 and -3/4. Okay, -3/4 is also included. The same situation applies. And if if this B is greater than A, then that means A minus B has to be less than 0. Good example is our previous problem. If I try and remember that right now, I believe it was 5 minus 8 equals -3. The same applies if both these numbers are negative. But if you're subtracting a negative, then it's the opposite. If A minus B, you have A minus B. If A and B, could have just put an ampersand there, but if A and B are in the set of negative rational numbers, and if B is less than A, something completely less, then A minus B has to be greater than 0. It will be greater than 0. Another example, if we're trying to flip this, then if we have -5 minus -8. Okay, it's not really flipping, but you know what I mean. You have 5 and 8. But this time both of them are negative. This -8, if you're trying to get rid of something that is extremely bad, which is bigger than the situation you had before, then that is going to be pretty good. You're going to have something, keep using something, that has to equal something that's greater than 0. And whether you know it or not, get 3. And I know, how exactly did you get the 3? And It's kind of simple, and I'll kind of deal with it later on with multiplication, but it's kind of quick. So 5 minus 8, that's equal as a negative 8 minus 5. Because you get 8 minus 5, that's 3. But then the 8 is kind of switched around, and then you get something negative. It deals with the distributive property. You get negative 8 plus 5. Switch that around by the commutative property, and then you get 5 minus 8. Same thing happens around there. There's a stay flip option, where this stays, and this kind of flips, where it's negative 5 plus 8. And voila, you get the same expression. And 8 minus 5, that's 3. If we have both A and B, A and, I use ampersand, A and B are, okay, they are just rational numbers, I guess. They're kind of real numbers, whatever. If they're the same, and A equals B, then A minus B equals 0. It's pretty much shown easily if you have A and B and they're equidistant. Oh wait, they're not. If A equals B, so they're in the same area, you have A here, and if you're going to subtract, you're going to go to the left of 0. You're going to go back to 0, the same amount from 0 to A, where a negative number or a negative operand would or could be an additive inverse to A is equal to negative B. Then A plus B equals, same thing happens if B equals negative A, yada yada yada, and you get on the number line, if they are equidistant, there you go, A and B, then that means whatever you have here, and then you have to plus it, the same distance of B, going to A equals negative B. Then this is just the negative version of that. And if you're going to add the same distance here, you're going to go back to 0. The negative number can also be a unary operand, meaning that you just put a negative in front of a number. You've already made it negative, so you sort of change the number by adding a negative. Even if you don't have a negative symbol, it could just be 1 is equal to negative 1. The negatives cancel out, because the negative version of a negative 1 number has to be 1, because they cancel out. That's basically the easiest way to say that whatever you do to multiplication, they just cancel out if they're the same sign. Maybe in class, so if you do positive times a positive, you get positive. Positive times a negative, you get a negative. You get a negative times a negative, you get a positive. And when you get a negative times positive, you get a negative.